Hey, what's up, Chem peeps? Who is ready for a thriller of a free response practice? Freon is a registered trademark of the Chemours company, which it uses for a number of halocarbon products. They are stable, non-flammable, moderately toxic gases or liquids which have typically been used as refrigerants and as aerosol propellants. These include the chlorofluorocarbons that cause ozone depletion, such as chloro-difluoromethane, but also include newer refrigerants, which typically include fluorine instead of chlorine and do not deplete the ozone layer. Two very stable compounds, Freon 12 and Freon 14, are used as liquid refrigerants. A Freon 12 molecule consists of one carbon atom, two chlorine atoms, and two fluorine atoms. A Freon 14 molecule consists of one carbon atom and four fluorine atoms. Carbon is the central atom in both molecules. So exciting, learning so many ways that chemistry is connected to real life things. Part A. In their respective boxes below, draw a valid Lewis structure for a molecule of Freon 12 and a molecule of Freon 14. Now, we're given some hints. We're told that carbon is the central atom in both molecules. We're told that Freon 12 consists of one carbon atom, two chlorine, and two fluorine atoms, whereas Freon 14 consists of one carbon, four fluorine atoms. Now, you are encouraged to work through the steps to determine the Lewis structures for each of these compounds, as you've practiced them up until this point in the year. However, if you recognize that carbon is the central atom and carbon must follow the octet rule, and that in each example it's surrounded by four atoms, in Freon 12, two fluorine and two chlorine, and in Freon 14, four fluorines, you should be able to recognize that the type of bond that's going to exist between the central carbon and each of those surrounding atoms is going to be a single bond in each case. Again, because carbon must follow the octet rule. Now, I'm going to complete the Lewis structures by including the lone pairs that we see on all of the terminal atoms. Whew. 2 points, one for each correct Lewis structure. And if you're confused about that or how to draw Lewis structures, time out. Go back and rewatch some of those videos about how to correctly draw Lewis structures for the class. All right, let's get to the good stuff. Subpart I. What is the percent by mass of fluorine in Freon 12? Remember, percent by mass calculation is the mass of the part over the mass of the whole times 100. In Freon 12, I have two atoms of fluorine. 2 times 19.00. That's the part. Now we want it out of the whole. So we've got our two atoms of fluorine plus our two atoms of chlorine plus our one atom of carbon. Whoop. All of that times 100. All right, let's jump to our calculator. 2 times 19, answer. Divide by parentheses, 2 times 19, close parentheses, plus parentheses, 2 times 35.45, close parentheses, plus 12.01, close parentheses, answer, times 100. Our percent by mass of fluorine, 31.43% fluorine. Boom. Subpart I. What is the percent by mass of fluorine in Freon 14? Similar calculation. Part fluorine, 4 times 19.00. Now we have 4 fluorines over our 4 fluorines plus the mass of that carbon. All of that times 100. Calculator. 4 times 19.00. Answer. Divided by parentheses, 4 times 19.00, close parentheses, plus 12.01, close parentheses, times 100. Answer. 86.35% fluorine. Boom. Stop and think for a moment. Makes sense that fluorine makes up a much larger percent by mass in Freon 14 than it does in Freon 12. Take a moment, pause the vid, stop and look at these two numerical setups. Math.
And will always love you.
Part B. Show a numerical setup using dimensional analysis. And determine the total number of moles of Freon 12 in 60.4 grams of Freon 12. 60.4 grams of Freon 12 is CCl2F2. Again, we're talking about this one here, Freon 12. We're using dimensional analysis To cancel out those units of grams, I'm going to put that initially on the bottom. First, convert into moles. 1 mole of CCl2F2, 120.907 grams. That comes from adding together the masses of all the individual elements in Freon 12. Calculator time. 60.4 times 1 answer divided by 120.907. If I round this to 3 sig figs, I get 0.500 moles of Freon 12. Boom. Answer using dimensional analysis. Dimensional analysis. Subpart I. Show a numerical setup using dimensional analysis. Dimensional analysis. And determine the total number of fluorine atoms in 60.4 grams of Freon 12. All right, now I'm going to restart here with the 60.4 grams, but you could totally pick up with the 0.500 moles since we're going to go there first anyway. I want grams to cancel out. I'm going to convert to moles of CCl2F2. 1 mole, about 120.907 grams. From there, I now want moles of CCl2F2 to cancel, and I'm going to convert to moles of F. For every one of these moles of CCl2F2, there are 2 moles of fluorine. Now, because I want individual atoms, I'm going to cancel out moles of F and convert to atoms of F using, you guessed it, Avogadro's number. Calculator. 60.4 times 1 answer divided by 120.907 answer times 2 answer times Avogadro's number 6.02 second E 23 close parentheses answer. To 3 sig figs, I get 6.01 times 10 to the 23 atoms of F. Boom. I have about Avogadro's number of atoms of F. Stop for a moment and think about that. If I have 60.4 grams of CCl2F2, I have about half a mole. And because every mole contains 2 moles of fluorine, a half a mole of CCl2F2 contains a mole of fluorine, which is Avogadro's number of atoms. Math.
Bittersweet memories. That is all I'm taking with me.
Part C. An HVAC technician, heating, ventilation, air conditioning, uses 60.4 grams of Freon 12 in one refrigeration process and 60.4 grams of Freon 14 in a separate refrigeration process. Is the number of molecules of Freon 12 used greater than, less than, or equal to the number of Freon 14 molecules used? Show a numerical setup using dimensional analysis to justify your response. All right, 60.4 grams of Freon 12, the CCl2F2. First thing I'm going to do is convert that to moles. And then from moles, I'm going to convert to molecules using Avogadro's number. All right, I'll do the setup for Freon 14 in red. We have the same mass, 60.4 grams. But now it's Freon 14, or CF4. Here, 1 mole is only 88.003 grams. So same mass, but the molar mass is different. It's smaller. Then convert to molecules. Again, use Avogadro's number for that. All right, let's jump to the calculator. 68.4 times 1 answer divided by 120.907 answer times parentheses 6.02 second E 23 close parentheses answer. We have 3.01 times 10 to the 23 molecules of CCl2F2. We have about half a mole of molecules. We've already done this calculation a couple of times in this problem. Let's take a look now at Freon 14. 60.4 times 1 answer divided by 88.003 answer. Notice that we have a larger number of moles of CF4 because our molar mass of CF4 is smaller.
And I will always love you.
Times parentheses 6.02 second E 23 close parentheses answer. 4.13 times 10 to the 23 molecules CF4. All right, to finish this, the number of molecules of Freon 12 is less than 3.01 times 10 to the 23 is less than 4.13 times 10 to the 23. The number of molecules of Freon 14 used. Boom, we are done.